Well, hey there everybody, thanks for tuning into this video. Today, where I'm going to try and do a little bit of explanation about negative exponents. Now, I'm not really going to explain too much about how they actually work, how you manipulate them, how you convert them into positive exponent expressions, but really I'm going to focus on what do they mean? What is this concept of a negative exponent and how does it work? Okay, how do we think about it? Okay, so first, I would like to start off with a comment that exponents really are an invention. Somebody decided that a way to express a certain type of quantity was to use these things called exponents, and they really are wonderful. They simplify our math work and they save time. So it's a very brilliant invention. But they are a symbol, and so here's an expression using an exponent, 2 with an exponent of 3, 2 to the third power. Now you know what that means. It means 2 times 2 times 2. That means that, so the exponent there is a number that means how many times you are supposed to multiply that base. Okay, very simple. You already know that, and you know that 2 squared means 2 times 2. But let me introduce possibly a slight shift in your thinking about what that exponent means. It is a symbol that has been defined to mean repeated multiplication. Okay, that's what I'd like you to think of that symbol meaning, is repeated multiplication. Now, okay, all fine and good, but what about a negative exponent? What does 2 to the negative 2 mean? Because you can't multiply a number times itself negative 2 times. That concept doesn't really seem to hold true for negative exponents. And my point here in this video, my friends, is that it actually does mean the same thing. It still is repeated multiplication, but we're going to take a little bit to get to exactly what I mean by that. The question of what it means, well, let's think about a negative exponent versus a positive exponent. Negatives are the opposite of positives. So perhaps we could think of a negative exponent as meaning the opposite of repeated multiplication. What do you think about that? Well, what would be the opposite of repeated multiplication? Well, repeated division? Is that what a negative exponent means? And my answer is, actually, it is. It does kind of mean repeated division, but with a little bit of a twist. Okay, so we're going to talk about what this negative exponent really means in the context of repeated multiplication, and I'm saying to you that it actually still does mean repeated multiplication in a certain way, and I want to explain that way to you. And along the way, we'll also cover this thing about a zero exponent. All right, so that'll be just a little extra piece of information for you. Okay, well, let's get started here. If I have a column of numbers, 2 to the third on the left side of that column, and I'm going to figure out what that means, put it on the right side, you know what's going to go there. 2 to the third equals 8, because it's 2 times 2 times 2. Okay, no big deal. And you also know that 2 squared is 4, because that means 2 times 2, etc. 2 to the first equals 2, and then finally we work our way down. We have this thing called 2 to the 0. Well, that's a strange thing. How can I multiply 2 times itself 0 times? That doesn't really make sense. But let's observe another pattern that we've set up here. If we think about as the exponents decrease from 3 to 2 to 1 and then down to 0, what we're doing with our quantity really is that we are dividing by 2. So 8 divided by 2 equals 4. And 4 divided by 2 equals 2. And so it would make sense then to keep that pattern going, be consistent, and say 2 divided by 2 equals 1. And what I'm going to introduce to you right now is the little twist about negative exponents, which will help us understand that. Dividing by 2 is the same thing as multiplying by 1/2, which is the reciprocal of 2. And so this is my main point for you folks, is that the whole concept of dividing a number, in other words, the operation known as division, is exactly the same thing as multiplying by the reciprocal. Okay? This is a huge and profound concept that once you fully grasp it and start applying it, it will make all of your mathematics more sensible, and you'll be a stronger mathematician for having this as kind of integrated into your thinking. So it's a really important concept. That was a crow just flying by. And so let's continue. Let's use this now to divided by 2, or 2 times multiplied by 1/2 equals 1. 2 times 1/2 equals 1. So 2 to the 0, following this pattern, then equals 1. And so that's great. Well, what if we wanted to continue this pattern? Let's keep on dividing by 2, or keep on multiplying by 1/2. 1 times 1/2 equals 1/2. Well, then the question is, well, okay, how do we express that? What kind of a symbol should we use to mean multiplying by the reciprocal of the base? And it turns out that if you simply continue the pattern of exponents, 3, 2, 1, 0, what would be next in that pattern? Well, yeah, -1 would be next. And so we express that as 2 to the -1st. It is not a negative number. It is actually repeated multiplying by the reciprocal. So we're going to multiply by the reciprocal of 2 one time. That's what the 2 to the -1st power means. And if I keep on going, then the next time I multiply by 1/2, I would get 1/4. 1/2 times 1/2 is 1/4. And that we could write as 2 to the -2nd. It's multiplying by the reciprocal of 2 times. And 1/8, 2 to the 1/3. So let's look at this. 2 to the -3rd equals 1/8. That's the same thing as 1/2 times 1/2 times 1/2, or 1/2 to the 3rd power. So you can see we've taken the reciprocal of the base and multiplied it times itself 3 times. That's why the exponent becomes positive, because it still really is repeated multiplication. But it's not repeated multiplication of the base, it's repeated multiplication of the reciprocal of the base. So 2 to the -2nd is 1/2 times 1/2, that's 1/2 squared. And here it is, folks, here it is. When you take any number to a negative exponent, again, it is not a negative quantity we're talking about here, at least not necessarily a negative quantity. It could be, but the negative exponent means repeated multiplication of the reciprocal of that base. That's what it means. Okay? Now, I'm sure that somewhere along the way in your math journeys, you have seen something like this in a textbook. A to the -n equals 1 over a to the positive n. Okay, and so this is expressed as some kind of a trick or a little thing that you do. You take the base and then you put 1 over that base and then you make the exponent positive. And that's all true, but it is obscuring this central core idea of what a negative exponent actually means. There's actually kind of leaving out a couple of steps here. Let me fill in the gap here for you. When you have a to the -n, that means 1 over a to the positive n. So it's repeated multiplication of the reciprocal of the base. Well, 1 over a to the n power, if we use our other laws of exponents, means I can take that exponent and apply it equally to the numerator and the denominator of that fraction. So I have 1 to the n over a to the n. Well, here's the thing. 1 to the n, or 1 to any power, is still 1. And that's why we get this extra thing here, 1 over a to the n power. It's not just a trick you do or some kind of physical manipulation of the symbols. It's actually kind of expressing the end result of this little chain of logic here. Okay, so that is what the negative exponent means. I hope that was useful to fill in those gaps right there. And by the way, any number that we take to the 0 power equals 1. That's in our chart there on the left, and it's true for all bases. Any base to this power of 0 equals 1. So let's summarize a little bit of what we've been talking about here. We've said that a positive exponent means repeated multiplication of the base, and a negative exponent means repeated, well, wait a minute, division? No, I don't mean division, even though division is, in a sense, the opposite of multiplication. I really mean repeated multiplication of the reciprocal of the base. So here's the terms that I want you to link up in your heads, folks. When you see the words negative exponent, or when you see a number with a negative exponent on, I want you to think reciprocal. All right? It's still repeated multiplication, but it's repeated multiplication of the reciprocal of the base. Okay? And that's our little twist to the idea of what a negative exponent means. I hope it was helpful. Watch the video again if you like. Ask me questions, do some more research, and by all means, be well and go do some more math.